Perfect. So good afternoon, everyone. Thanks for being here today. And my name is Chen Chen, and I'm a PhD candidate at Civil and Environmental Engineering Department at Rice University, advised by Dr. Daniel Cohen. So today I'm talking about the potential geothermal deployment in the US, focusing on the power system and also the industrial sector. So for geothermal energy, it's a valuable resource to decarbonize either the power system or also provide clean heating for the industrial sectors. And recent advancements in technology focusing on the enhanced geothermal system, or we call it EGS, could be applied to both sectors and especially for the industrial heating, it can provide low and medium heat for those industrial process heat. So unlike most of studies that only focus on one energy sectors, so these studies, we developed a sector-coupled energy models that you could co-optimize the both power sector and the industrial sector. So the model includes major energy supplier, including coal, gas, oil, nuclear, solar, wind. And so especially for coal, gas, and oil, they could either provide power generation or industrial heat. And for the geothermal, it can also serve as the both way. It can generate power via the EGS, and also it can provide deep direct use heating for those industrial process. And in the model, we also introduced two clean options via electrifications, which are the resistant heaters and also industrial level heat pumps. So on the map here, you can see the subsurface temperatures we required from the previous studies. And those temperatures are extremely important that can determine the cost of EGS, and it can also determine if the temperature is sufficient to supply the industrial heat at different sectors. And so we used a model called GeoFires to estimate the capital cost and also the O&M cost for the geothermal and for both EGS and deep direct use. And we substitute the drilling cost from the 2024 Fervo's latest assessment from their pilot testing in the Southwest Utah. And Fervo is the geothermal startup based in Houston and doing amazing work on the piloting testing of the EGS. So the model optimized the both power generation and industrial heat, and it shows the geothermal can play a very important role in 2030, as you can see the maps here. So for the EGS, due to the low efficiency to convert heat to electricity, then you mainly will see deployment in the West United States, including California, Nevada, Idaho, Wyoming. But for the heat, for deep direct use heat to support the industrial process heat, you can see there's a wider adoption across the nation, including states like Texas here, Louisiana, Illinois, and Indiana, where those states requires the pretty low heat requirement for the industrial process. But you should note those results only indicate the cost-optimized solutions. The actual deployment of the geothermal could be much longer and much more complicated due to the, the explorations, permitting, and seismicity analysis. And that concludes my presentation, and I will be in the poster session later on. And if you have any questions, please feel free to come to me. Thanks.
Excellent. Thank you very much, Chen.